It is May 2020 and we are in the COVID lockdown. I have not been able to access my barber because of this lockdown. That explains my bushy face. Again, because of this lockdown, people are now exercising from home. They're not being allowed to go jogging on the streets anymore like they used to before. All these are effects of the lockdown. Now, what am I trying to say? We keep encountering situations where one decision gives a result or gives birth to some deal of consequences. You find that one event happens and a lot of other things are happening as a result of that event. For example, a live example is my face. Because of the COVID-19 lockdown, I have not been able to have my hair cut, and as a result, my face is getting bushy by the day. In the example I just gave, when I say the president gave a directive that people should not leave their homes, that is an input. And that input led to an output, among other outputs such as me having a very bushy face. In mathematics, these inputs and outputs are represented in terms of figures. The relationship between the input and output is best described in what we call mathematical functions. My name is Arnold Rangakuramia, and in today's lecture we shall be discussing everything functions. Now, if you do not want to be bored by the introduction of this topic, the basics, and you want something specific about this topic, just make use of the timestamps in the description below. In today's session, we get to talk about relations and functions. Coming up. So what exactly is a function? Now, of course, a function by definition, if I may say, a function is simply a process that changes a set of input numbers into a set of output numbers. Now, functions are normally represented by equations such as these you're seeing on your screen. We have right here, we have y is equal to 3x plus 4. This is an example of a function. Of course, this value of x is what we call the input, and this value of y is what we are calling the output. Now, this is just a straight line equation that we are calling a function. We can also represent functions in another way. This is what we call function notation. What we were calling y is equal to 3x plus 4 can be represented as f in brackets x is going to be equal to 3x plus 4. Now this f is this is what we call function notation. Like this value of y is the same as is what is being represented as f of x. The f of x in literal terms in this case will mean that the function of x where the input, the function f where the input is x is given by 3x plus 4. Now, this means that for every value of input we put here, we are going to produce a certain output. Looking at our function here, if I put the value of x here is 1, if I put my input there as 1, my value of output is going to be 7. How? Because if I put 1 here, it's going to be 1 times 3, which is going to be 3 plus 4, giving us 7. So if I put 2 here in this value of x, 2 times 3 is 6, 6 plus 4. So my value of f of x, so my value of y, or call it my output, is going to be 10. If I put here a 3, 3 times 3 is 9, 9 plus 4 is 13. So my value here is 13. Likewise, if I put a 4 here, 4 times 3 is 12, 12 plus 4 is 16. So my value of y, or the f of x, is 16. What I'm trying to show us here is that for every input we are putting in here, we are getting a specific, or we are getting a certain amount of output. In this brief table you're looking at, you're seeing that we are having a group of input values and a group of output values. When these values of x are such that they are in a group, we collectively call them the domain of the function. And also when these output values are grouped like we are seeing here, we call them the range. When in a group, the input number is called the domain of the function, while the output is called the range. Now, of course, unless has been stated otherwise, the domain is simply all real numbers for which the equation produces outputs. it is always going to be assumed that for every function that we shall be dealing with, or for every function that there exists, unless it is stated otherwise, the assumption here is that the domain is always comprised of real numbers, and these real numbers are such that they should always give us an output. To illustrate this further, let's take a look at this function. We have the function f where x is the input is given by 2x minus 1, and all this term is under the square root. We are saying that unless it is specified, the input value or the domain is supposed to be all real numbers that are supposed to be giving us an output. Whatever. If you look at this question, the value of x here, it just cannot be all real numbers, or it just can't be, it's going to be specified. Why? 2x minus 1, if we are to put a value of x here in such a way that the answer we get here is going to give us a negative number, it will mean that the value of the y value or the output value here will be undefined. Why? Because we do not have the square root of a negative number. The rule is that the domain of a function is all real numbers for which the equation produces outputs that are real numbers. But in this example, the domain is going to be set to be x is greater than or equal to a half, since this value here, 2x minus 1, cannot be negative. So that means that for this case, x is going to be greater than or equal to a half. So that when we put a half here, a half times 2 is going to be 1, 1 minus 0 is 0. So 0 is equal to 0. But if we put a figure here like that is less than a half, let's say we put here 0, it's going to be 2 times 0. 2 times 0 is going to be 0. 0 minus 1 is negative 1 right here in the brackets. Square root of negative 1 gives us an output that is undefined. So it means that in this case, that when it comes to the input values are set to be greater than or equal to a half, so that we make sure that what we are having in these brackets here is always a positive number. And also that simply also means that the output, or call it the range, is, in this case, the range is set to be all non-negative numbers. So for some functions, it can also just be predetermined. For example, in this function, we can simply say that the domain is set to be that x is greater than 5. We can choose on any set or any limitation for this function. So the general rule here is this, that unless the domain is explicitly stated, like in this case, the domain is assumed to be all real values that produce real numbers as outputs. Now we can represent functions in another way. For example, a function with a small finite domain can be described by a set of ordered pairs instead of an equation like this. What you're seeing right there are what we are calling ordered pairs, and ordered pairs is just another way we can show functions. Now if you look at these ordered pairs, we see that this and that, this is the value of x, that is the value of y, x, y, x, y, x, y. And from these ordered pairs, these values that are in red, the values of x, are the ones we are calling the domain, 0, 1, 2, 3. And then the ones that are in blue are the ones we are calling the values of y, which are represented here, 2, 1, 3, and 8. So the domain is that, and this is our range. So from these ordered pairs, you're seeing that every input is corresponding to a certain output. Every input is corresponding to a certain output. Or every value of x is corresponding to a certain value of y. Now, this is one thing about functions that you should know. That when it comes to functions, one value of x corresponds to one value of y. One value of x, if it is 1, this one, when it is fed into a certain function, it's supposed to give us a specific value of y. A specific value of x is supposed to be giving a specific value of y. But then there is sometimes when this thing is not respected. You'll find that, let's say this is 0. When you feed in 0, you find that you're getting 2. And maybe let's say you put in here 0 also, and you find that you're getting another value that is not 2. Let's take a look at this in this illustration. If you look at this illustration R, these are ordered pairs. If you look at these ordered pairs R, you find that when we feed in 1 in the input, we are getting 3 as the output. Again, this very 1 is giving another output here of 4. So what does this mean? This means that this 1, the same input 1, is giving us 2 different outputs. Likewise, in these other 2 ordered pairs, you're seeing that we are having 2 here and 2 here. When the input is 2, the input 2 is giving us 2 different outputs, which is 9 and 4. So because here the input, one input is giving us 2 different outputs, one input is giving us 2 different outputs, this distorts the uniqueness of a function. What do I mean by the uniqueness of a function? The uniqueness of a function is such that one input is going to explicitly give us one output. If the input is 1, it can only give us one output as far as these ordered pairs are concerned. But when you look at these ones, it is one input, 1, but this one input is giving us 2 different outputs. So this ceases to be a function. These ordered pairs are not representing a function. These ordered pairs are representing what we call a relation. A relation, therefore, is simply a rule that connects 2 or more things. And a function is just a type of relation, because remember, the function also is a function is simply a special kind of relation. So a function is more like a subset of the relation. The relation is just any equation that relates 2 things, or any rule, or any expression that could be algebraic, it could be a quadratic equation, it could be a relation. Simply is a rule that connects 2 or more things. And just like a function, a relation tells us what to do with some sort of input so that we get a specific kind of output. The difference between a relation and a function is that a function has this rule that one input gives us one specific output, yet when it comes to a relation, one input can give us more than one output, like we've seen here. F of x is equal to y is the function notation, and this simply means that the value of f, it simply means that the function f where x is the input is giving us y. Now if you're to represent these ordered pairs in terms of this function notation, you find that the function f where 0, which is the value of x, is the input, is giving us 2 as the output. Right here, the function f where x is the input is giving us 1 as the output. The function f where 2 is the input is giving us 3 as the output. And finally, where the function f is 3, right there, in this ordered pair, it's giving us 8, the value of y, as the output. So this is how we can represent these ordered pairs, as using the function notation. First example is more of an objective. If 3, 2, 4, 2, 3, 1, 7, 1, and 2, 3 is to be a function, which of the following pairs must be removed? Now if you look at this ordered pair right here, the question is asking us that if this ordered pair is to be representing a function, it means that one of these ordered pairs must be removed. Now from this we already know, or from what I've been explaining earlier, that the uniqueness of a function is this, that one input corresponds to one output specifically. And if you look at the inputs here, we have 3, 4, 3, 7, 2. That is more like the domain. But from this domain we are able to see that the domain here, the value of 3 here and the value of 3 here, or the value when 3 is the input, it's giving us 2 outputs. When the input here is 3, it's giving us 2 as the output. When the input here is 3, it's giving us 1 as the output. So it means that when the input is 3, it's giving us 2 different outputs, which is 2 and 1. And if one input is giving us 2 different outputs, that ceases to be a function. This ordered pair therefore is representing what we call a relation. Now, in order for us to make this a function, it means that we have to get rid of one of these ordered pairs. We can either get rid of 3, 2, or we get rid of 3, 1. if we get rid of one of these, it means that all the remaining ordered pairs will simply represent a function, because every input is corresponding to one output. So if we are to answer this question, if you look at these objectives on which of these to eliminate, our answer is definitely going to be A. So in order for us to make this set of ordered pairs a function, we are simply going to remove 3, 2. And when we remove that, you realize that the rest of the ordered pairs is such that one input is giving one specific output. One input is giving one specific output, and that makes it a function. Looking on to our next one, we are being asked that what value must be excluded from the domain of x, y, or from this domain x, y, where we have been given a function that y is given as x plus 2 divided by x minus 2. Now, which of these should be excluded from the domain? Like, which value of x must be excluded from this for this to hold? We had stated earlier that unless the domain is explicitly stated, the domain is always assumed to be all real values that produce real numbers as outputs. Now, if you look at this expression, there's not been any rule that is stated that the domain is supposed to be running from this value to that value. So it means that that rule applies here, that the domain is going to be assumed to be all real values that produce real numbers and outputs. So now it means that this value of y is supposed to be, the value of x that we are going to feed in here is supposed to be such that it produces a value of y that is a real number. But if you look at this expression, y is equal to x plus 2, divide that by x minus 2. If we put our value of x here, let's say, if you look at our value of part A, negative 2, if we put negative 2 here, it's going to give us negative 4 in the denominator. So whatever we get here, if we divide by negative 4, we shall get a value of y that is a real number. So we can't get rid of negative 2. So in other words here, y would be, if x was negative 2, y would be negative 2 plus 2, giving us 0. Divide that by negative 4, y would be 0. So let's go to B. If you look at B, if B is 0, if the value of x is 0, that would be 0 plus 2, that's going to be 2. Divide that by negative 2, giving us the value of y as negative 1. So again, we can't, B is not the answer. So meaning, if we look at part C, C is, if we put 2 plus 2 right here, it's going to give us 4 in the numerator. In the denominator, 2 minus 2 is going to give us 0. 2 divide that by 0 is going to give us a number that is not defined. We can't, as in 2 divide, any number divided by 0 gives us an undefined kind of number. So what does that mean? 2 divided by 0 gives us a value of y that is not a real number, a value of y that we do not understand. So probably maybe C would be, but let's go to D. D is 2. If it's 2 and negative 2, well, we already ruled out that if we make x the negative 2, it would still give us a value of y that is a real number. So in this case, our answer for this number is C, because if we make the value of x2, it's going to give us 2 minus 2 down here, and our value of y would be an undefined number. And we said that unless the domain is explicitly stated, these values of x here are assumed to be all real numbers that are supposed to produce real numbers as outputs, or that are supposed to give us a value of y that is a real number. Right now we are going to get into what we call combining functions. We will start off with an illustration here. We have functions, and a function called f and a function called g, with both of them having inputs as x. Now, these functions f and g can be combined. We can combine them by either adding them up, we can combine them by subtraction, we can combine them by multiplying them, we can also combine them by dividing them. So we'll start off with adding the functions. This is the notation. We shall first go through the notation. The notation here of some of a function, we have a function f and a function g. We call it f of x or g of x. Both functions have the input as x. So if we are to add them, it will mean that it's going to be f plus g. These are the two functions we are adding, and the input is both x. Adding this function is the same as saying f of x plus g of x, or the function f where x is the input, or the function g where x is the input. This is the notation. That is how we represent sum of a function. Then we have what we call the difference of a function. Of course, the difference of a function here, we are subtracting the functions. The function f minus function g, where x is the input. This is one way of representing it. This is the same as saying the function f where x is the input minus the function g where x is the input. We can also combine functions by multiplying them, and in this case we are saying the product of a function. The product of the function in this case is representing by that dot, f dot g. F dot g, where x is the input variable, is the same as saying f of x dot g of x. In this case we are multiplying the functions. Then we have what we call the quotient of the function. Of course, the quotient in this case is that we are dividing the functions, where f divided by g, where x is the input. And when we divide those two where x is the input, we have, it's the same as saying f of x, divide that by g of x. But the condition here is that the function, whatever function is in the denominator, should not be equal to 0, because if this function is equal to 0, then it would mean that the quotient of the function would be undefined. So the condition is that this is only valid when whatever function is in the denominator is not supposed to be equal to 0. Then we have what we call the composite function. A composite function is more like you place a function in a function, and it is represented by that round dot. It is more of a dot, it is just more of a small round circle. That the function f, being a composite of function g, or f small round circle g of x, where x is the input, is the same as saying f, and in f into where the input is another function. In simple terms, a composite function is more of a function of a function, or it is a situation whereby you're having a function that is acting as an input in another function. So in this case, you'll see that the function g of x in this case is acting as an input of the function f of x. So we're having a function being an input of another function. So of course this is the notation, that f with the input g of x. Same with here, we are having the function g, and this function g is such that its input, or its value of x, or its input, is another function f of x. So right here we are having a number. We have that if f of x is going to be equal to 3x minus 2, that is a function f where x is the input, and that's the function. And then we have function g where x still is the input, is given by x squared minus 4. Write an expression for each of the following functions, and our value of a there is f plus g. We are supposed to add them. Of course, f plus g of x, this is the same as saying f of x plus g of x. So the function of x in this case here, according to our question, is 3x minus 2. So this is going to be 3x minus 2 plus our g of x. Our g of x is x squared minus 4. So we go ahead and add them and get our final expression. So this is going to become 3x minus 2 plus x squared minus 4. So this is going to become, we arrange the collect like terms, look at x squared plus 3x. This is minus 2 and minus 4. Minus 2 and minus 4 gives us minus 6. We end up with a quadratic equation, and that's the answer. In part B, we are trying to find the difference of these functions. Of course, f of g of x is the same as saying f of x minus g of x. Definitely this is going to end up being f of x, in this case being 3x minus 2 minus g of x. Our g of x is x squared minus 4. This is going to end up being 3x minus 2 Then we open brackets. -1 times x squared is going to give us negative x squared. Then we have -1 times -4 gives us +4. That's going to become, of course, we collect like terms. This is going to become 3x, that is minus x squared. Then we have -2 here and +4. -2 plus 4 is going to give us +2. So that gives us the answer. Or if I may rearrange this in the form of a quadratic equation, it turns out to be x squared plus 3x plus 2. Then we have here, we are multiplying the two. We have f dot g. This is the same as f times x. This is same as f of x. Multiply that by g of x. So this is going to become f of x. In this case, f of x is 3x minus 2. Multiply that by g of x, which is x squared minus 4. So definitely these are two brackets multiplying each other, so we are going to go ahead and open the brackets. So this becomes 3x times all these brackets, which is going to be 3x times x squared minus 4 minus 2 times, this is minus 2 times the whole bracket, minus 2 into x squared minus 4. So opening brackets, 3x times x squared is going to give us 3x to the power 3. 3x times -4 is going to give us -12x. We have -2 times x squared giving us -2x squared. Then we have -2 times -4 giving us +8. We go ahead and rearrange this to make it simpler. This becomes 3x cubed minus 2x squared minus 12x plus 8. And we can't simplify it any further than that. That's our answer right there. Then we have f over g of x. F over g, of course, this is more of, we are finding the quotient of these two. This is the same as saying f of x, divide that by g of x. Dividing these two, we have f of x giving us 3x minus 2. Divide that by g of x. G of x is x squared minus 4. And I think that's pretty much it. It's going to give us 3x minus 2 over x squared minus 4. You can simplify this further. X squared minus 4 is the same as x squared minus 2 squared. This is difference of two squares. And difference of two squares ends up giving us 3x minus 2. Divide that by, this gives us x minus 2 into x plus 2. Difference of two squares, the property. So definitely, remember we said that when it comes to quotient, the key thing here is that the denominator is not supposed to be equal to 0. This is how we illustrated it here, that when we are looking at the quotient function, it is supposed to be such that the denominator, the g of x, is not equal to 0. So since here the quotient function is such that it is 3x minus 2 over x minus 2 into x plus 2, the condition here is that if I make x 2 here, if I make x 2, it's going to be 2 minus 2, this is going to be 0, and it will make this whole denominator 0. Likewise, if I make this x here -2, it's going to make this whole thing -2 plus 2, giving it 0. So it's going to make the entire denominator 0, and this function, the quotient function, would be undefined. So the condition here, therefore, we shall write and say that the value of x in this case is not supposed to be equal to plus or minus 2. That's the condition for this quotient function to stand. So looking at the final, it's a composite function where we have the function f times a small circle g of x. This is the same as saying that we are looking for the function of x where our input value is another function g of x. So what is our function of x, for example? Our f of x is 3x minus 2 right there. 3x minus 2. That's our function f of x, our function where x is the variable. And according to this composite function, if this is our function xf, it is such that the input value is another function. So it means that in this place of x, we're supposed to put there the function g of x. So this is going to become 3, multiply that by, in the place of x we are putting g of x, which is this whole thing. So this is going to become x squared minus 4, that is what we are putting in the place of x, minus 2. And so we go ahead and simplify that. That is 3 times x squared is going to give us 3x squared, then 3 times negative 4 is negative 12 minus 2. And we shall end up with 3x squared, negative 12 minus 2 is negative 14. That's pretty much it. Then we have g f. Then we have gf of x. This is the same as saying g, small round circle, where the input of is f of x. So what is our g of x? Our g of x is x squared minus 4. Now, in our g of x, in the place of x, we are supposed to put another function called f of x. So in the place of x, we are putting a function. So that's going to become, in the place of x squared, our f of x is 3x minus 2. So we are going to put here 3x minus 2, that is squared, minus 4. And that's going to become, so we go ahead and expand this. This is definitely going to become 9x squared minus 2 times 3 times 2. 2 times 3 is 6. 6 times 2 is 12 minus 12x plus 4. Then this is an expansion of this, minus 4. And so we shall end up with 9x squared minus 12x. So in this session, we are going to look at how to combine functions. We are going to look at a few worked examples relating to functions, how to combine them. So let's get started with number 1. We have f of x giving us as 3x squared minus 2x plus 4. They're telling us find f where the input is negative 2. In other words, they're trying us to find the value of the function or the value of y when x is negative 2. So we go ahead and substitute in there. It's going to be 3, the function is 3x minus 2x plus 4. So when x is negative 2, it means it's going to be 3 times negative 2 squared minus 2 times x minus 2 times negative 2 plus 4. This is going to become 3 times, negative 2 squared is 4. So it's 3 times 4 minus, okay, this is negative 2 times negative 2, which is positive 4. So we shall simply say plus 4, then plus 4. So 3 times 4 is 12 plus 4 plus 4 is 8. 12 plus 8, the answer is 20. So our answer is E. So if f of x is going to be equal to 4x minus 5 and g of x is 3 to the power x, then find f g of 2. So this is a composite function. Let's first find the function inside g of 2. So meaning that g of 2 is giving us, first of all, we know g of x to begin with. G of x is giving us 3 to the power x right there. So it means that g of 2, so when the value of x is 2, is going to be giving us 3 to the power x. In this case, x is 2. So this is going to be 3 times 3, which is 9. So if the g of 2 is 9, it means that this function is going to become f of g of 2. Our g of 2 is 9, so it's f of 9. So what is the function when the value of x is 9? First of all, f of x is 4x minus 5, yeah? So it means that if f of x is going to be 4x minus 5, so f of 9, so in the place of x there is a 9, so it means that where there is x we put 9, it's going to become 4 times 9, minus 5. That's going to become 4 times 9 is 36. So it's going to become 36 minus 5. 36 minus 5 gives us 31. So the answer is D. And then we have this number. If f of this composite function is given by 4x squared minus 8x and f of x is x squared minus 4, then what is g of x? So we have been given f of x. If you look at this question, this is f of x. This has been given. F of x is x squared minus 4. And according to this expression, f of x giving us x squared minus 4, the value in the function, the input for f, in this case was another function that we are calling g of x. So the question is that what is this function g of x? I may approach this in two ways. Let's look at the first way. So well, we can go ahead and get these answers a, b, c, d, e and try and plug them into here, because these are possible functions of g of x, the g of x we are looking for. So we are going to plug in a right there, or b in there, then we plug in c in there, then we plug in d right there, or we plug in e right there, and then we see that if we plug in this function g of x in the place of x in this expression, do we get this expression? A number that gives us this expression, when we plug this in here, will be the answer. So let's get started. So let's begin with a. A is 4 minus x. We know that f of x is going to be x squared minus 4. So if 4 minus x is given right there, so this is going to become f of 4 minus x is going to give us 4 minus x minus 4. This is squared. So this is going to become, of course, this is the whole value of x. This is the input, actually, the input. So that's the input right there. So this is going to become, of course, 4 squared is 16 minus 8x plus x squared minus 4. And this is going to become x squared minus 8x. Then 16 minus 4 is 12 plus 12. Now this expression is not that, so it means that a is out. Of course, if we go to b, part b, if we put x, part b, plugging in x here is simply going to still give us, putting x there, it's going to simply give us x minus 4. So b is out of the picture. Let's try c, 2x minus 2. If we put 2x minus 2 in the brackets here as our input for this expression, is it going to give us that? So we try. It's going to be, this becomes f of 2x minus 2 is giving us x squared. In this case, it's going to be 2x minus 2. This whole thing is squared minus 4. This is going to become, expanding this is giving us 4x squared minus 8x plus 4 minus 4. Of course, this is going to become 4x squared minus 8x. And if you look at this 4x squared minus 8 is consistent with this 4x squared minus 8. In this case, the answer here is C. So the question again, if this is equal to that and this is equal to that, this composite function, it means that the g of x is going to be 2x minus 2. In other words, if our function of f is such that the value of x here is the function, and which function is 2x minus 2, if we plug in 2x minus 2 there, then our output is going to be that. So that was one way of doing this. Now what if they gave us this very same number, and what if they didn't give us these answers and we were supposed to just find it the way it is? How would we go about that? So this is an alternative way of looking at this. We have this composite function f into g of x is giving us 4x squared minus 8x, and f of x is giving us x squared minus 4. So what is g of x? Now to begin with, this is a composite function. We are having the function g of x inside f. So we shall start with this. We have f of x is giving us x squared minus 4. That is the original function. But now what happens? Let's substitute in the value of g of x in this expression, because it is a function where the input is another function g, where the input is also x. So in this case, this means that if we put f, the function f in brackets where the value of x, now the input has become g of x, this makes this function to become g of x, where there is x is where you put g of x. So it becomes g of x, this is squared minus 4. So what is the function where f of g of x is this expression? F of g of x, this composite function, is given by 4x squared minus 8x. So that is exactly what we go ahead and do. We go substitute this here. We say that 4x squared minus 8x is giving us this expression. G into x, all this is squared minus 4. So what we do here, we go ahead and solve this, and we make g of x the subject of the formula, and we will be able to get our answer as required by the question. So this is going to give us 4x squared minus 8x. This 4 comes this way, it becomes plus 4, is giving us g of x, this thing is squared. So we have a quadratic equation here in x. So factorizing this becomes 4 outside the brackets into x squared minus 4x minus 2x plus 1 is giving us g of x, and this whole thing is to the power 2. So this continues to be 4 into factorizing this quadratic expression is going to give us x minus 1 squared, is giving us g of x, and this whole thing is squared. So definitely, to make this whole thing squared, because we want to eliminate this square, we do it this way. This is going to become 2 into x minus 1. This whole thing becomes squared. This becomes g of x. This whole thing is also squared. So definitely, for us to get rid of this square sign, we find the square root on both sides. This square root sign cancels with that. You remain yourself with this becomes g of x, remains with, of course, the square root sign cancels with that square. We remain with 2 into x minus 1, and this means that g of x is equal to 2 into x minus 1, which is the same as 2x minus 2. And if you look into our answers, 2x minus 2 is C. That is the right answer. So that's the second way of looking at this. What values must be excluded from the domain of this quotient f over g if this is divided by that, or from this quotient whereby the f, that, and so on. So after factorizing this quadratic expression, we end up with, in our numerator, we end up with x minus 1 into 3x minus 1. Divide that by 3x squared minus 2. Continue with this, we shall continue it from here. That's going to become x minus 1 into 3x minus 1. Divide that by the bottom. Actually, it's 3x minus 3, not 2. So this common factor here is 3. It's going to become 3 into x squared minus 1. This is the same as saying x minus 1 into 3x minus 1. Divide all that by 3, multiply that by x squared minus 1. X squared minus 1 is the same as x squared minus 1 squared. X squared minus 1 squared gives us a difference of 2 squares. And how do we express difference of 2 squares? The identity in this case is going to become 3 into x squared, x minus 1 into x plus 1. And definitely this is going to become x minus 1 into 3x minus 1. Divide that by 3 into x minus 1 into x plus 1. So our quotient function turns out to be like that. It turns out to be x minus 1 in brackets into 3x minus 1, all that in brackets, divide that by 3 into x minus 1 into x plus 1. Now when you're dealing with quotient functions, remember we said that the denominator is not supposed to be equal to 0. So looking at this, 3 into x minus 1 and x plus 1, which number should we exclude from the values of x, or which value must we exclude from the domain that could make this entire term to become 0? Now of course, if you look at this expression, x minus 1 means that if we make this value of x a positive 1, this will give us 1 minus 1 giving us a 0, and it makes this whole term 0, so meaning that x should not be 1. Also, if you look at this term, if we make this value of, if x was negative 1, it would mean that as far as this bracket is concerned, negative 1 plus 1 would make this bracket 0. Making this bracket 0 would make this whole term equal to 0, and that would make the value of this quotient undefined. So to avoid that, to avoid this denominator being equal to 0, it means that x should not be equal to either positive or negative 1. And so meaning that if we are to go back to our question is asking us to find the values which must be excluded from the domain of the quotient of the functions f and over g. If f of x was that and g of that, the answer is definitely D. X should not be positive or negative 1, so meaning that our answer here is D. So we're having this question that looks related to like question number 3, the one we had done just a while back. It's telling us that if g of x is giving us 3x plus 2 and g of f into x is giving us x, then find f of 2. So we realize that this is a composite function where any value of x here that is put here is going to be equal to x. So meaning that if we have our value of x here as 1, this thing is 1. If this is 2, the value of x here is 2 in the function f, it means that the overall is 2. If it is 3, it is 3 there, and so on. So again, what we do, we shall start with our original expression. This is a composite function where g is the one outside, and we are having the function f inside the function g. The function g of x is given by 3x plus 2, so it is g into x is given by 3x plus 2. Now, when we put in the place of x that is inside the function, we put there f of x. So in the place of x, we are going to put this expression f of x. So g into the other function f of x is still going to give us 3. Now in the place of x, we put that function f of x. So it's going to be 3 into the brackets f of x, like that, plus 2. So this is going to become g. Now g of f of x, remember right here, it has given us the impression that g f of x is equivalent to x. So it means that g of f of x in this case is x. So we shall put x here. Is going to give us this expression. Of course, this expression is going to be 3 times f of x plus 2. So we go ahead and make f of x the subject of the formula, because we want f of x first, then we shall put in the value of 2 later. So f of x, the expression is going to become x, making this the subject of the formula means this is going to become x minus 2, divide that by 3, is going to give us f of x. So meaning that the function f, where x is the input, is giving us x minus 2, divide that by 3. But now the question requires us to find the value of f where the input is 2. So we shall do exactly that here. So meaning that f where the input is 2 is going to give us 2 minus 2 over 3, and this is going to give us 0. So from our objectives here, the answer is A. So in this question, they're telling us that if the function p where x is the input is given by 4x minus 6 and p where the input is a is equal to 0, then what is the value of a? Of course, the value of a here they're telling us that when in the place of x, when we put a in the place of x, the overall expression, the overall function is 0. So we'll begin by quoting the original expression p of x. P of x, or the function of p where x is the input variable, is given by 4x minus 6. So where x is a, meaning that when our function p is such that the value of x is a, given by 4 times value of x where there is x is where we put a, so it's going to become 4a minus 6. Of course, where a is, this p of a is equal to 0. So this thing is equal to 0 is going to give us 4a minus 6. So go ahead and find the value of a. This is going to become 4a being equal to positive 6. When we divide both sides by 4, we shall end up with our value of a as 3 over 2. So our value of a is 3 over 2, and that makes C the answer. In this session, we get to look at the inverse of a function. Now, speaking of an inverse of a function, it is another way of saying the reverse of a function, and it is denoted by that power -1. We know that functions can be labeled as f, g, h, or any letter. The inverse of a function is denoted by that power -1. For example, if the function is labeled g, the inverse of the function will be g to the power -1. If the function is labeled h, the inverse of that function will be h to the power -1. Now, of course, for a function to have an inverse, it's supposed to be satisfying a certain relation. And the property of this relation is such that that very function, and if that very function is made a composite of its inverse, it is supposed to be equal to this relation, and all that is supposed to be equal to x. So it means that if you're having two functions and one function is f of x and the other is the inverse, or the inverse of that very function, then for that to be true, those two functions are supposed to satisfy this relation. And from earlier on, this simply means that these two are composite functions, not multiplication. To illustrate that further, we have this function here. F of x is going to be equal to 4x plus 2. The question is asking that if f of x is equal to 4x plus 2, then is the inverse of this same function given as x minus 2 over 4? We need to prove that this is true. Of course, for us to prove whether this function is indeed an inverse of that, we are going to use this relation. We are going to use this relation and see if we do this, it's going to equal to x. Then we are going to work out this as well and see if it is equal to x. And if this relation is fully satisfied, then we can conclude and say that yes, it's indeed true that this function is the inverse of the other. So we get started with the working. So f of x composite, its inverse, this is going to be this is interpreted as that the function where the input is its inverse. So we know that f of x definitely is 4x plus 2, so this is going to be 4 times x. Now in the place of x, if this is f of x, if f of x is given as 4x plus 2, so it means that in the place of x we are going to put the inverse. This is what we are representing here, that so where there is x we are going to put the inverse. So in this case we are going to put f times x minus 2, divide that by 4 plus 2. Of course, from here this 4 is going to cancel out with that 4, and we are going to remain with x minus 2 plus 2, and we shall end up with x. So that's the first bit. We have been trying to verify this part of the relation here. So we are going to go ahead and do the same thing but the reverse way in this form. So we are going to do a reverse of this. So the composite function of those two, this is interpreted as the inverse, where the input is going to be f of x. And this is going to be given by, of course, the inverse function in this case is x minus 2 over 4. So if f of x is x minus 2 over 4 as given here, so it means in the place of x we are putting there the function f of x in the place of x. So it means in this expression where there is x, we are going to put the function f of x, 4x plus 2. So meaning that in this part it's going to become 4x minus 2, it's what we put here, then minus 2, divide all that by 4. So definitely this is going to become 4x minus 2 minus 2, divide that by 4. This will become 4x minus 4 over 4. This will give us 4 into x minus 1, divide that by 4. This is supposed to be 4x plus 2 minus 2. So definitely this is going to be 4x plus 2 minus 2, and this is plus 2 minus 2, this is giving us 0. So it means this is going to become 4x plus 0, that is plus 0. And this ends up being 4x over 4. This is out. So 4x over 4, the 4's will cancel out and you remain with the value of x being that. So from here you notice one thing. You notice that when we make this a composite function of that in this expression as exhibited here, we ended up with our final answer being x. Likewise, when we did the second step here, which is this and that, you found that our final answer was x, which is still satisfying this. So if we are to go back to the question is asking that if this function f of x is given by 4x plus 2, then is this function its inverse? From our workings here, the answer is yes. So we will conclude by saying that yes, it's the inverse. If the function f is given by these ordered pairs, now find the inverse of this f, this relation f. So of course the inverse here is going to be this is the value of x, that's y, this is the value of x, that's y, this is the value of x, and that's the value of y. And we said that the other way of finding or of calling the inverse of a function is more like the reverse of the function. So it means the ordered pairs therefore are going to become, this is 1, 2. So the reverse of this is definitely 2, 1. Then this is 2, 3. The reverse of this is 3, 2. Then this is 3, 2. The reverse of this is 2, 3. And definitely this is now the inverse of that. This is our answer. Let's say we are having a point 3, 1 right there. A point 3, 1. The inverse of this function is going to be the reverse of this, which will be 1, 3. That is 1, 3. So we are having this point right there and another right here. If I may use another this red point there and there, you realize that these points are on either side of this straight line. So this brings us to the conclusion that the graph of an inverse function is a reflection of the graph about the line y is equal to x. So meaning that if you're having an inverse function this side, if you're having a function this side of the line, the inverse function is a reflection of this function along this line. So it means that it will be reflected in this part of the graph. So the graph we are seeing right there is just another illustration of what I've been talking about. This is the graph of the line y is equal to x. So if we are having this quadratic function is to be reflected along that line. Of course, if this quadratic function is reflected along that line, this is the inverse of that quadratic function. And you realize that the inverse of the quadratic function upon reflection in this along this line is giving us a relation. This is yet another example. This is the line y is equal to x. We are having this function, it's a straight line, and the inverse of this function, like we had said, is a reflection in this line y is equal to x. So the inverse of this function is this line reflected through y is equal to x. And in this case, the inverse of the function is also a function. Now that we've seen that we can get the reflection of the function or a relation by simply reflecting it in the line y is equal to x, how then can we find the inverse of the function algebraically? So in these few next examples, we are just going to show how we can algebraically, or by calculation, we can get the inverse of a function. In our question right here, we are having, if the function f where x is the input is given by 5x plus 4, find the inverse of that function f. So finding the inverse of that function f, we get started off by first of all acknowledging this f of x. Let's call this f of x y. So it's going to become y is going to be equal to 5x plus 4. So now we want to find the inverse of this function. What we do is that we are going to make x the subject of this formula. When we make x the subject of this formula, and then we flip the two. Remember, we said that the inverse of a function is more like the reverse of a function. So if it's the reverse of the function, it means that x is going to become y and y is going to become x. And that's it. So let's start it off this way. So we are going to first make x the subject of the formula, and so this means this is going to become we flip 4 comes this side, this becomes y minus 4 is going to be equal to 5x. So when we divide both sides by 5, we end up with our value of x being equal to y minus 4 over 5. So since this is we are making it this is the inverse, is more like we are trying to flip it or find the reverse. It means that we make this value of x becomes back y, and this value of y becomes x. So it means in our next step we shall just say that y therefore is going to be equal to x minus 4 over 5, and therefore we shall say that the inverse of this function f, the inverse of the function where x is the input, is equal to x minus 4 over 5. So this is how we find the inverse of this function algebraically. This is the same way you would go and plot this on a graph, and then you reflect this function in the line y is equal to x. You would still end up with a function of this nature. So we have this one too. We have f of x is going to be equal to x squared. What is the inverse? Again, let's call this y. Y is going to be equal to x squared. So our task is to make x the subject of the formula. So making x the subject of the formula, we eliminate this square. It becomes the square root of y is going to be equal to x. Therefore, here x is going to be the square root of y. So what we do is that we make x become y, we make x y and y x, we flip them. So it means that y is going to be equal to the square root of x. Therefore, the inverse is square root of x, like that.
In mathematics, we learn by doing. I hope you're not just watching this like you're watching a movie. Make sure you have a pen and paper to take some notes.
We have these multiple choice questions. If f of x is given by x, f of x is equal to x, the inverse of f, which is f to the power negative 1, could be represented by one of these. So if the f of x is going to be equal to x, if this function f of x is equal to x, let's call this y, meaning that y is going to be equal to x. Of course, already here x is already the subject of this, so meaning that x is going to be equal to y. So if we to flip those, y will still be equal to x. What does that mean? It means that the inverse of x is still going to be x, and our answer here is A. Another here, the inverse of of this function f. This function f is in form of ordered pairs 1 2 2 3 3 4 4 1 this and 5 2 would be a function if the domain of f is limited to. Now they're asking us this would be a function if the domain. Now by the domain we are talking about the values of x. We have 1 there, we have 2, we have 3, we have 4, and we have 5. 1 2 3 4 5. Now this function, this let's call this a relation. The inverse of the relation f, this would be a function if the domain of f is limited to, and they've given us these alternatives. Now, first of all, what is the inverse of these ordered pairs? Let's first find the inverse, because the question is talking about the inverse of this. So let's first find the inverse. Of course, the inverse of this is going to be given by, this is 1 2, the inverse of this point is, or the reverse is 2 comma 1. Then here it is, this is 2 3, it means the inverse here is 3 2. Then this is 3 4, meaning the reverse is 4 3, or 4 3. Then here the reverse of this, or the inverse, is 1 comma 4. Then this is 5 2, the reverse is 2 comma 5. So now actually the question is talking about the inverse of these ordered pairs. And the inverse of these ordered pairs is this one right here. And they're telling us that this inverse here would be a function if the domain of f is limited to a certain set of numbers. Now let's look at the domain of this inverse. If you look at the domain of this inverse, we have 2 right there, we have 3, we have 4, we have 1, then we have 2 again. Now what do we know about a function? We know that a function is supposed to be one input going to equivalent to one output. One input is corresponding to one exact output. If a certain input is having more than one output, then it's not a function, it's just a relation. But now let's look at this relation here, the inverse of this thing. We have 2 3 4 1 and then 2. So you realize that we have two inputs here. We have 2 comma 1, we have 2. We have a 2 here and a 2 here, but the input of 2 is giving us an output 1 here and an output 5 here. So meaning that this is not a function. This ordered pairs is not a function because we're having an input 2 giving us two different outputs of 1 and 5. So it means that if we are to make this a function, we have to eliminate one of these, because the uniqueness of a function, or the major characteristic of a function, is that one input corresponds to one exact output, not one input having two different outputs. So it means we can either eliminate this or that. So that the question is that what would be this inverse would be a function if the domain, that means if the values of x of f, the values of x of this one are limited to this. So if this thing is to be a function, it means that the values of x that are corresponding to these two, one of them has to be eliminated. So it means that we are either going to eliminate this or that. So if you're to come back to this 2 comma 1 corresponds to this, and this 2 comma 5 corresponds to that. So it means that if this is to be a function, we have to eliminate f. The domain of f should be limited to. Now it either has to be we either have to eliminate 1 or we have to eliminate 5, one of those two. We eliminate either 1 or 5, and if we eliminate this one and maybe therefore we kill this point, it would mean that the inverse is a function, or we eliminate this. So we'll come here and see which one has been eliminated in our answers. So the domain would be limited to 1, 3, 5. No, that is not it. A is not it. Part B, we have 1, which is that, 2, 3, and 4. This one, B, looks correct. C is 1 and 5. These are the ones we are eliminating. C is not. Part D is 1, 2, 4, and 5. So both are still there. C, D is not it. Then we come to part E, is 1, 2, 3, 4, and 5. Part E includes all of them. It's not. The answer here is B. That B is having 1, 2, 3, and 4. So meaning that we've eliminated this one. So part B is the answer here. We have these multiple choice questions. In today's session, we get to look at what we call even and odd functions. So we'll start straight away with what an even function is. Now, an even function is one where when you plug in negative x in the place of x, the same function will return. We shall use illustrations to paint the picture clearer regarding this. So let's look at this. We have a function f of x is going to be equal to x squared. Now the input value here is x, and it's giving us x squared. So now if in the place of x we put 4, this is going to become 4 squared. That's going to give us 16. When it gives us 16, we go and do the same thing and put a negative 4 in the previous place. When you put a negative of the same function here, it's going to become negative 4 squared, and it's still going to give us the same number 16. Now, because when we plug in a negative value, it's going to give us the same answer, 16. This makes f of x being equal to x squared an even function. This is the other illustration. We are having another function, f of x is given by x squared plus 3. Now let's choose a number 5. When x is 5, we put 5 in the input there. Of course, when x is 5, here it's going to become 5 squared plus 3. 5 squared is 25 plus 3, giving us 28. That is when we put in the place of x 5. So now let's go ahead and put negative 5 in that same place. That is what we did here. When x is negative 5, when you put negative 5, it's going to become negative 5 squared plus 3. It's still giving us 25 plus 3, giving us 28. Now, when we plugged in a positive 5, it gave us 28. When we plugged in a negative 5, it still gave us 28. So that property makes this an even function. Again, an even function is one where when you plug in a negative x in the place of x, the same function will return. And that is exactly what we mean. All even functions are symmetric about the y-axis. Now, by saying that they are symmetric about the y-axis, it's like saying the y-axis is like a mirror, or it's a line that divides the function into two equal parts. Let's take a look at a few graphs to illustrate this further. Now, if you look at this graph, this is more of a quadratic graph. This quadratic graph is an even function. Why is it an even function? If you see this quadratic graph, it is symmetric about the y-axis. In other words, the y-axis divides it into two equal parts. So it is symmetrical about the y-axis. This is what we mean. Now, when it comes to odd functions, and it's a bit different for odd functions, that instead a negative value is going to be returned when we change. Let's take a look. We have the function f of x is given by x to the power 3. So let's make x be equal to 2. When we put 2 in there, when the input value is 2, we are going to get here is 2 to the power 3, giving us 8. So now in the same place, we are going to put negative 2 here. When you put negative 2 to the power 3 is going to give us negative 8. So now with an odd function, when we put a value of x in the place of value of x, when we put in a negative value in the place of x, like we have done here, you're going to end up coming with a negative answer or a negative function. So that brings us to that relation for odd functions, that for odd functions, so that brings us to that relation regarding odd functions, that for odd functions, this is exactly what happens, that when we put a negative answer, actually, this is more accurately put when we say that when we put a negative value in there, it's going to return a negative, like that. And of course, this negative, if you multiply by negative on both sides, it turns out to be this expression. So that is for odd functions. For This is how the relation comes out about for odd functions, that when you put in the place of x, you put a negative x, it's going to return this as your answer. Now it's important also to note that odd functions have a rotational symmetry about the origin. By rotational symmetry, it means that if I was to turn this thing, if this was my center and I was to turn this graph by 80 degrees, it would still look exactly in the same, it would have the same shape if I turned it 80 degrees. When this is my center, it would look the same. So that is what we are calling rotational symmetry. So they have a rotational symmetry about the origin. Now take note, there are some functions whereby the conditions that we've been discussing earlier are not met. They do not meet the condition for it to be an odd, or they do not meet the condition for it to be an even function. Now, of course, if you encounter a scenario where neither of those conditions are met, it means that that function is neither odd nor even. But also we said that even functions are symmetrical about the x, and odd functions are symmetrical about the origin. We are going to go through a series of graphs to try and identify which graph is representing an even function, which graph is representing an odd function, and which graph is representing neither of the two. So the first graph here is a quadratic graph. Of course, this is symmetrical about this axis. It's symmetrical, so this makes it an even function. It's a function. It's an even function. Then if you look at this thing, it is not symmetrical about the x-axis, and it is also not having any rotational symmetry about the origin. So this one is neither odd nor even. Then we have this one right here. It's not symmetrical about the y-axis. In other words, this y-axis is not splitting it into two equal parts, and also it's not having a rotational symmetry about the origin. So this one is neither. It's neither odd or nor even. Looking at this one, if you look at the y-axis splits it into two equal parts, meaning it's having a symmetry about the y-axis. So this one is an even function. This one right here, it's not symmetrical about the y-axis. It is not having a rotational symmetry about the x-axis, about the origin, meaning this one also is neither odd nor even. It's neither odd nor even. Looking at this graph right here, it is having, if you look at the y-axis, it splits it into two equal parts, or into two parts that are identical to each other. So it is having, it is symmetrical about the y-axis, meaning that this represents an even function. This one right here is having no rotational symmetry, and it is not symmetrical about the y-axis. So this one is neither odd nor even. This one right here, it's not symmetrical about the y-axis, meaning the y-axis is not dividing it into two, and also, but it's having a rotational symmetry about the origin. In other words, if you're to turn this into 180 degrees, it would look exactly the same. If you turn this into 180 degrees, it would look exactly the same. So it means that this is an odd function, since it's having a rotational symmetry about the origin. If you look at this one, it's not having a rotational symmetry about the origin, and it is not having a symmetry about the y-axis. It's not symmetrical about the y-axis, so meaning this one is neither odd nor even. Then looking at this function, it is symmetrical about the y-axis. In other words, this and that, it's more like a mirror. This is reflected in that direction. So it is symmetrical about the y-axis, so this makes it an even function. Looking at this one is symmetrical about the origin. In other words, if I was to rotate this graph by 180 degrees, it would look exactly the same. So because it is symmetrical about the origin, it is an odd function. This one is not symmetrical. It's neither symmetrical about the y-axis. It's also not symmetrical about the origin. So this one is neither odd nor even. So we have taken note of that. When we want to identify graphs that are representing odd or even functions, the key thing to take note of here is this, that when it comes to odd functions are symmetrical about the origin, or they have a rotational symmetry about the origin. And when it comes to even functions have even functions are symmetrical about the y-axis. So we have some numbers here to work out. We are required to classify each of the following as even, or odd, or neither. And from there, of course, we are not going to draw graphs. We are going to calculate them and see which ones are even, which ones are odd, and which ones are neither of the two. Shall start with part A. Now let us be reminded, first of all, that when it is for an even function, when we plug in a negative here, it's going to return the same function. When it is an odd, when we plug in a negative right there, it is supposed to return something like that, like we had seen earlier. Let's take note of this as we get started. We have our part A here as f of x is giving us x to the power 4 minus x squared. So meaning that f of negative x means it's going to give us negative x to the power 4 minus negative x to the power 2. And of course, negative x to the power 4 is still going to give us x to the power 4 minus negative x to the power 2 is still giving us x. So you realize that when we plugged in a negative, it still gave us this x to the power 4 minus x, which x to the power 4 minus x is f of x. In other words, here, when we plugged in f negative x, it produced this, which is this. It produced f of x. So this means that this is an even function. That is how we arrive to that conclusion that part A is an even function. The function is part B, f of x is 3x squared minus 5x. That's the function. So let's plug in a negative here and we see what we get. So f of negative x is going to give us 3 into negative x squared minus 5 into negative x. So this is to the power 3, it's 3x cubed, so this is to the power 3 right there. So of course here 3 into negative x to the power 3. Negative x to the power 3 is going to give us negative 3x to the power 3 minus 5 times negative x gives us negative 5x, like that. And now there, if you're to put this negative outside, it becomes negative outside the brackets into 3x cubed minus 5x. And if you notice that this is going to become minus, and what is in the brackets here is 3x cubed, which is 3x cubed minus 5x minus 5x. This is minus f of x. So if you notice that when we plugged in the negative, when we plugged in f of negative x, we ended up with that. So this is a property for odd functions. So it means that this is an odd function. So part C, we are having f of x is giving us 2x plus 5. So let's plug in a negative here. A negative, that is f of negative x, is definitely going to give us 2 times negative x plus 5. And then definitely we are going to end up with negative 2x plus 5. Now definitely this it does not satisfy any of these conditions. This does not satisfy any of these conditions. It does not satisfy this condition. it does not satisfy this condition. So what that means that part C, the function part C is neither odd, it's neither odd nor even. Now we have a function part D. The function D is f of x is equal to 3x squared minus 4x. Let's plug in the negative. F of negative x, what do we get? Does it return the same function? That's going to become 3 into negative x squared minus 4 into negative x. And this is going to become, of course, negative x squared is going to still giving us 3x minus negative x, of course it's minus negative 4. This is more like 3x plus 4. That is f of negative x giving us that. Now you realize that this and this is squared, that is squared. Of course this and so you realize that there is no connection between this function and that function in terms of what we call an odd number or an even number, or in terms of what we call an odd function and an even function. So what does that mean? It means that this is neither odd nor even. So what kind of conclusion are we coming up to here when it comes to odd functions and even functions? This is the conclusion. For even functions, when I plug in a negative x, this is the original function. If I plug in a negative x and my working is such that it is going to bring back the original function, when I plug in a negative x, it means that that is an even function. That when I plug in a negative x, it brings back the original function. Likewise, for odd functions, if I plug in a negative, this is the original function. If I plug in a negative right there, and when I plug in a negative in this function and I work it out, and it comes out that it's going to bring a negative of the original function, a negative times the original function, which is this one. It means that, that is in this case, that if I get a negative, when I put in a negative in the original function, it's going to give me negative the original function, then that qualifies to be an odd function. Now if I work it out like in these last two numbers, and it so happens to be that neither of these two conditions of the odd function and the even function are met, then that function is neither odd nor even. In this session, we are going to do some 3 multiple choice questions regarding the topic on odd or even functions. Now, which of the following relations are even? We have Roman 1, Roman 2, and Roman 3. We have y is equal to 2, y is equal to x, and then x squared plus y squared is equal to 1. Which of these relations are even? That's what the question asks us to do. So we shall basically try to identify how these things look like. For example, if you look at y is equal to 2, if I may sketch a graph of y is equal to 2, y is equal to 2 is, maybe this is 1, 2. Y is equal to 2 is more like a straight line. This is straight line y is equal to 2. Then this other f of x is equal to x, that graph looks like this. F of x is equal to x, or the graph y is equal to x looks like that. This is y is equal to x, and then Roman 3 x squared plus y squared is equal to 1. This is the equation of a circle, so it means that it's going to look like that. It's equation of a circle, and the question is, which one of these is even? Of course, I'm using the graphs to try to figure this out. We said that an even function is symmetrical about the y-axis. Now if you look at this, it is symmetrical about the y-axis, so meaning that this one is even. If you look at this, it is not symmetrical about the y-axis, but it is symmetrical about the origin. In other words, if I flipped this or rotated it 180 degrees about the origin, it will look exactly the same. So it means that this one is an odd function. Then if you look at this, you realize that this circle, first of all, it is symmetrical about the y-axis. I mean, if you look at it, it is more like this is it is mirrored this way. It is symmetrical about the y-axis. And also, if I was to rotate this function about the origin, I flip it in the about the origin, like in 180 degrees, you'd find that it will still look the same. So it means that this function is both odd and even, this function. So getting back to the question now, they're asking us which of the following relations are even. Of course, the ones that are really even, we have this one and that one. So the answer there is 1 and 3. Our answer there is D. Then we have another question there, still with the same. Which of the following relations are odd? We have y is equal to 2, which is this one. We have y is equal to x, which is right there. Then we have x squared plus y squared is equal to 1, which is that circle. Which one of the following relations are odd? The ones that are odd, we have this one and that one. So the answer here is 2 and 3 are odd. So looking through our objective answers, we have D. Okay, which of the following functions is neither odd nor even? Now let's remind ourselves. First of all, for it to be even, it means that when I plug it negative x right there, it's supposed to give me back the original function. And if it is odd, if I plug in negative x there, it's supposed to give me a negative of the original function. This is the premise we shall be using. So let's analyze part A. Now when you look at A, we are having the input values here. We have 1, we have 4, negative 1, negative 4, 0. So when we put in 1 here, when the value of x is 1, the value of y is 2. So again, when we come and put it negative 1 in the place of x where there was 1, we put it negative 1, we are still getting back 2. So it means that this relation or this function is representing an even function. Another thing that proves this is this. Another thing that proves it is this. This is x. When the value of x is 4, we have 7. Now in the place of 4, when we put a negative 4 here, we are still getting back the same value 7. So it means that A is an even function, so that won't work. Let's go to part B. If you look at the ordered pairs in B, if you look at, for example, when we plug in x, when x is 1, we get 2 as value of y. Now instead of putting positive 1, when we put negative 1 in the place of x, we are going to end up getting a negative answer in the place of y, negative 2. So this satisfies this condition. This is an odd function. The same can be seen here with 4. When I plug in 4, positive 4, I get positive 7. When I plug in negative 4, I get negative of this, negative 7. So this is an odd function. So B is also not the answer. Let's go to C. If you look at C, we have y is equal to x to the power 3 minus 1. Y is equal to x to the power 3 minus 1. Let's call this f of x. F of x is going to be equal to x to the power 3 minus 1. Now let's plug in a negative x here. So f of negative x, what is it going to give us? F of negative x is going to give us negative x to the power 3 minus 1, and definitely this is going to give us negative x to the power 3 minus 1 as our f of x. Now this does not, it's not giving us this back. This is not consistent with this. This is also not consistent with this. So C is neither odd nor even. So I think that C would be the ultimate answer. In this session, we shall simply do a number of worked examples from the topic of functions. Now the examples here, we have number 1, we have number 2, then we'll get to number 3, number 4, and finally number 5. You may feel free to first pause the video so that you first attempt the questions, and thereafter watch the video to see if you get the correct answers. So let's get straight into it. Number 1 is telling us that if f of x is equal to 4x minus 8, then part A, what is f of 2? Now if you look at this function, f of x is equal to 4x minus 8, where there is x, when x, if you may look at it this way, that x is in the brackets, so when we look at this linear function, whatever is here is what is substituted here. So now if you look at part A is saying that what is f of 2? The function where the value of x is 2. Now since in the brackets we are having x and this is the function, so in the place of x we have 2, it means that even in this function where there is x is where we are going to put 2, and then we'll be able to get the answer to this expression. So in this case this is going to become 4 times x, the value of x is 2, 4 into 2 minus 8, and that's going to become 4 times 2 is 8 minus 8, and that is going to give us 0. That is part A. Let's get to part B. Part B is what is f of 3. We are going to do it like before. F of 3 means that it's going to become, our function is 4 times our value of x. In this case our value of x, there is 3 in the brackets, minus 8. And this is going to become 4 times 3 is 12 minus 8, and our answer right there is 4. Let's go to part C. Part C is what is the function where the value of x is mouse. So it means where there is x, we are simply going to put that word mouse. So part C, it's f of mouse is going to be equal to 4 into brackets. Now where there was x, in here there is mouse, so we shall put here the word mouse minus 8. Mathematically we can't go beyond this, so that's the answer. Part D, if f of x is 16, what is the value of x? So now still our f of x is equal to 16. So what is the value of x in this case? Now of course f of x is equal to 16. Our f of x, according to our question, f of x is given by 4x minus 8. So our f of x is the same as 4x minus 8. That is going to be equal to 16. So you can go ahead and find the value of x. In this case it's going to become 4x is going to be equal to 8 comes this side, it becomes 16 plus 8. So we have 4x giving us 24. When we divide both sides by 4, we end up with our value of x as 6. And that's our answer. Part E, we are being told that if the function whereby the value of x is 2b is going to be equal to 28, what is the value of b? So we go ahead and find the value of b. Now remember our function up here is f of x is equal to 4x minus 8. It means that whatever is in the brackets is what is supposed to be put here. Now right here, what is in the brackets, our value of x is 2b. So it means that in the place of x here we are going to put 2b. So this is going to become 4 times, in the place of brackets we put 2b minus 8. That's going to give us 28. So we open brackets here, 4 times 2 is 8b minus 8 is equal to 28. And so this, our 8b becomes 28 plus 8. 8b is equal to 36. When I divide both sides by 8, I shall end up with my value of b as 4.5. Now part F. Part F is telling us that f of c plus the function of where the value of x is 2c is equal to 8, find the value of c. So we go ahead and find the value of c now. Of course, from our original function, the original function is f of x is equal to 4x minus 8. Looking at this function where there is x is what we put here. If there is 2 here, we put 2 here. If there is 3 here, we put 3 here. Because the function when the value of x is the function of this variable is given by that function. Now here, when you look at this statement, in our brackets we are having the value of x being given as c. So it means that according to this expression, this is the same as saying f of c, our value of x is c. So now when we put c right there, it means that this 4x, this is also going to become a c. So that is how we do our next step. We substitute, so this is going to become 4c minus 8, plus, again, here this is f of x, our value of x is 2c, so in the place of x here we shall put 2c. This was an interpretation for f of c, plus, now this one is going to become 4 times x, our value of x is 2c minus 8 is equal to 8. So we go ahead, simplify this expression and find the value of c. So this is going to become 4c minus 8 plus 8c minus 8 is going to give us 8. So this becomes 4c plus 8c, 12c, then minus 8 gives us minus 16, is going to give us 8. So we have 12c being equal to 8 plus 16, that is after 16 coming this way, and it becomes a positive after crossing the equal signs. So this becomes 12c is giving us 24. Divide both sides by 12. We shall end up with our value of c as 2. So doing part G is going to become, remember our initial function, we say that f of x is going to be given by 4x minus 8, and we also said that where there is x, we substitute in that expression. So whatever is put in these brackets here is what is representing what we put here in the expression. So in this case, we're being told that f of 3d minus 7 is equal to 12. Now, in the brackets, we're having this whole expression. It means that this whole expression is what is taking up this value of x. This value of x is a linear equation, and so that is what we are going to substitute for in this expression right here. So this becomes 4x, 4 times our value of x, which is this whole expression, which is 3d minus 7 minus 8. Minus 8 is equal to 12. So we go ahead and open brackets and find the value of d. So this becomes 12d minus 28 minus 8, giving us 12. So this is going to become 12d minus 36, giving us 12. 12d is going to become, this 36 comes this side, it's a negative 36, crosses the equal signs, comes this way, it becomes positive 12 plus 36, and then we end up with our value of 12d giving us 48. When we divide both sides by 12, we end up with our value of d as 4. Now in our number 2, we are having a table that is giving us values of x and then the values of f of x. Now the values of f of x in this case are 1, 3, 5, 7, 9 and 11. It means that when we plug in these values of x in this function, we are able to get these as our answers. These are the values of f of x, or if I may say, if this is the value of x, this is the corresponding value of y. Now looking at this, we are being told that for the function in the table besides, what is the function where the value of x is 3? Now in this case, the value of x in that case, in that bracket, is 3. So we shall come to the value of x and look for 3. 3 is right there. So it means the function f of x, the value of y, or the value of this function is 5. So for part A, the answer is 5. If I may go to part B, if f of A is equal to 7, what is A? Now we are being told that the function when the value of x is A, the answer we get is 7. So now if the function when the value of x is A is 7, then what is A? Now for us to get to the value of A, it means we need to go and find where the whole function, the value is 7. And if you come to our table, where A is 7 is right there. I mean where f of x is 7 is right there. And this value of A has been replaced by x. Like our value of x is actually A. So f of A is 7. So when f of A is 7, it means the value of A here is 4. So it means that this value of A here is 4. So when the value of A is 4, or when the value of A, or in this case when the value of x is 4, the function is equal to 7. Now let's go to part C. We are being told that if f of 2, or when the value of x is 2, the function is equivalent to b. What is the function of 2b? So it means we need to first find b. Now to find the function f, when f of 2 is equal to b, so to first get the value of b, it means we've been told that it is b when the value of x here is 2. So we come to our table. When the value of x is 2, f of x is going to be 3. So it means that if this is our value of x here is 2, f of x is 2. So the function here is equal to 3. So it means that f of 2 is 3. Therefore, our value of b is 3. Now that we know that our value of b is 3, now we can go ahead and find f of 2b. So it means that in this case it's going to become f of 2b is giving you f of 2 times our value of b, which is 3. In this case it's going to be f of 6. So what is our f of 6? What is the function when the value of x is 6? So we can go ahead and find that. What's our function when our value of x is 6? The value is 11. So it means that this is going to be, so our f of 2b is 11, and that's how that number is. Number 2 ends like that. Now if g of x is equal to x squared, then we need to answer part A, B, and C with reference to this expression, with reference to this function. We are being told that the function of g when is equal to g of x, the function g where x is a variable, is given by x squared. So now what is the function of g when the variable is negative 2? So first of all, we know that the function g of x is equal to x squared. The function g when x is the variable is given by x squared. So what is g when the variable is negative 2? Therefore, this is part A. So g when the variable is negative 2, like we are saying here, is going to mean that where the variable is, we substitute here, it becomes negative 2 squared, and this is going to become negative 2 times negative 2 and gives us positive 4. So we go ahead and find part B. Part B tells us that if g, the function g when with a variable m is equal to 36, find the value of m. Remember, all this is in reference to that expression. So it means that our variable has become m. In this case, where there is x, we have put m. Our variable has become m. In other words, the value of x now is m. And they're telling us that when we come and put m right there, our value, the value of this expression of the function is 36. So it means in this expression, g of x, our value of x has become m. It means that if there is m here, it means that this is the same as seeing m squared right there. So this becomes m squared is the same as 36. To go ahead and find the value of m, we find the square root on both sides. This goes with that. m becomes, this square root of 36 is either a positive 6 or a negative 6. So the value of m, the values of m are actually 2. That is our part B. Again, now g, the variable g, where the value of x in this case now has become w, is equal to 12. Find g of 2w. So gw is equal to 12. So first of all, we seek to find the value of w. So it means that if g is equal to, originally the variable was x, and when the variable of x, it gives us x squared. So now if the variable is w right there, it means that this is supposed to be also w squared. We just substitute. So it means that this becomes w squared here is given by 12. So for us to go ahead and get the value of w, we find the square root on both sides, so that this goes with that, you remain with w, giving us the square root of 12. Now we have the value of w, but the question requires us to find the variable, the g of 2w. So we go ahead and substitute that right there. So what is g of 2w? Now g of 2w is going to become, of course, g of 2w, remember from our initial expression, it is g of x is equal to x squared. What is in the brackets here is what takes up the place of x in the expression. So here what is in the brackets here is 2w, so that is exactly what is going to take up the place of x in this expression, which is going to become 2w squared. So this is going to become 2 times w. Now we got w as the square root of 12 times the square root of 12, and all this is squared. So we can go ahead and find our answer. This squared, of course, this is going to become 2 root of 12 times 2 root of 12. So this is going to become 2 times 2 is 4 times, of course, a square root. A square root of a number times the square root of the number gives you that very number. So this is going to remain times 12. And of course, 12 times 4 times 12 gives us 48. And that is our answer. So going on to number 4, we have delta x is given by 1 minus 3x. So if delta x is given by 1 minus 3x, what is delta 2? So here in essence they're saying that what is delta 2? In the place of x there is 2. So what is going to be this expression? So if I may rewrite the solution here, delta x is given by 1 minus 3x. So meaning that delta 2 is 1 minus 3, in where there is x is 2. So meaning that here is the value of x is 2. So this becomes 1 minus 3 times 2, which is 6. And our answer is negative 5. Now we have part B. If delta A is equal to 4, then what is A? So delta A, first of all, is that from this expression, delta x, which is our question, is given by 1 minus 3x. And we are being told that delta A is equal to 4. It means that when the value of x is taken up by 4, if the value of x is taken up by A, we get an expression as 4. So if this is our expression from the question, we are being told here that delta A is equal to 4. So delta A, it means that this has been taken up here. This is our A. So it means that when our value of x is A, it means that this whole expression, this value of x also is now A. So if we may write the next step in that regard, it's going to become 1 minus 3a is going to give us 4. So this becomes minus 3a, giving us 4 minus 1. And our value of a here is 1. So let's go on to part C. We're being told that what is delta 3 over delta 1? Delta 3 over delta 1. That's going to become now delta 3. From here, our value of x in this case has become 3, so we substitute for 3 here. and this becomes 1 minus 3. Our value of x is 2, so this is 3 times 3. 3 times 3. Divide all that by delta 1. It means this is becoming 1 minus 3 times 1, like that. So go ahead and find the expression here. This is going to become 1 minus 3 times 3 is 9. Divide that by 1 minus 3. And this is going to become negative 8. Divide that by negative 2. And definitely our answer here is positive 4. So in our number 5, which is definitely the final number in this session, we are having a graph of f of x right here, and we have a few questions to answer about this in reference to this graph. We are being told that for the function graphed above, like you're seeing, what is f of 1.5. Now if you look at our graph, this is they are asking us that what is the value of this function when the value of x here is 1.5. So of course this is our value of this is our x-axis, and this right here is our y-axis. So now when they say f of x when x is 1.5, what is this whole function? It's like they are saying what is the value of y when x is 1.5. So we come here and look for where 1.5 is. Definitely 1.5 is right there, and if you look at 1.5 here, it's corresponding to a value of y as 2. So meaning that the function when the variable x is 1.5, f of 1.5 is equal to 2, or it's the same as saying the value of y is 2 when x is 1.5. So that's part A. Part B, we are being told that if c is greater than 0 and f of c is equal to 1, what is c? So now what is c? So what is c when the value of the function is equal to 1? Or in other words, they are saying that when the value of y is 1, what is the value of x? Because in the brackets here is the variable, and our value of x in this case is c. So we look for f of c, or the value of y, when it is 1. When our value of y is 1, if I may come here in this, our value of y is 1, or our f of c is 1, is this line. This is the line where it is 1. So when our value of y is 1, there are two possible values of x. We have this value right here, we have this value right there. That is according to this graph. According to this graph, when our value of y is 1, or when our value of f of x is 1, the two possible values of x is this and that. But then the question is saying that if c is greater than 0 and f of c is equal to 1, what is c? Now we got this, and we have their two possible values, and of course the value here is negative a half, comma 1, and then this one right here is 2.5, 2.5, comma 1. Now since the question is saying that the r value of c is supposed to be greater than 0, our value of x here is supposed to be greater than 0. If you look here, the value of x here is less than 0, so it means that the value of x they're talking about is this one, which is 2.5 or 2.5. So the value of c here is 2.5. So let's look at part C. For how many values of x is f of x is equal to 3 over 2? So how many values of x do we have when the f of x, or when the value of y is 3 over 2, if I may simplify that like that? So how many values of x exist when the value of y is 3 over 2? So 3 over 2 is the same as 1.5. So we shall go and look for the value of f of x is equal to 1.5, or call it the value of y to be 1.5, and we see how many values of x are there. So we shall come here and look. Our value of y is equal to 1.5 is right there, 1.5. This is the value, 1.5. This is the line, y is equal to 1.5, or call it f of x is equal to 1.5. This is the line. So how many values of x are there? Of course, if you look at this function, This line crosses this at that point, at this graph at that point, and it also crosses it at that other point. So what does that mean? It means that when our value of y is 1.5, there are two possible values of x, this value and that value. So the answer to this question, for how many values of x is f of x is equal to 3 over 2, the values are 2. And that brings us to the end of this. In this session, we are going to look at what we call linear functions. Now, a linear function is just a polynomial function whose highest exponent or whose highest power is 1. And of course, linear functions you can write them in form of this. This is ax plus by plus c. In this case, a, b, and c are constants. This is equal to 0. Or you can write it in this form, y is equal to mx plus c, where m stands for the gradient of that linear function and c stands for the y-intercept. By linear function, the other way is more of a straight line equation, an equation of a straight line. And when you're dealing with straight line equations, the highest power of x is always 1. And that is what qualifies it to be a linear function. So definitely, if you look at our write-up here, this is one form of expressing the linear function. You can express them in this form. And of course, this is coming after making y the subject of the formula in this expression. When you make y the subject of the formula in this expression, we end up with this expression, and this expression, if you look at it closely, it's exactly in this form, where negative a over b is the m, and c, negative c, is right there, the y-intercept. In writing the equation of the line containing 6,5 and having that slope of 3 over 4, I'm going to write this equation in two forms. There is what we call the point-slope form, and then there is what we call the slope-intercept form. So we'll begin with the point-slope form. Now, with the point-slope form, the form looks like this. That when you're writing the equation of a line, it's going to be y minus y1 is going to be equal to m into x minus x1. Now, the value of m here stands for the gradient, and these points y, the points y and x right there are just arbitrary points. It's an arbitrary point, x comma y, and then y1 and x1 is more like the point that is given. For example, in this question, we have 6,5. So our point 6,5 becomes our point x1, y1. And so we're simply going to come and substitute it in here. So it means this is going to become y minus our y1. Our y1 is 5. That is going to be equal to our value of m, which is the gradient. It is given, or the slope, it is given as 3 over 4, into our value of x, which is an arbitrary point, x minus x1, which is 6. And this becomes the equation of the line. It's our answer. And now this is the point-slope form of the equation. We can write this equation another way. We can write it in the slope-intercept form. And now when we're writing it in the slope-intercept form, this is when we'll use the general equation of y is equal to mx plus c. That is the point-slope form. Now we are going to look at the slope. In the slope-intercept form, it is y is equal to mx plus c. The value of m stands for the slope or for the gradient, and then the value of c stands for the y-intercept. So right here we have the point 6,5. So what we are going to do, we are going to have to first find the value of c. So we are going to substitute. This is the value of x, that's the value of y. So the value of y in this case here is 5, is going to be equal to the value of m, which is the slope or the gradient, which is 3 over 4, multiply that by the value of x, which is 6, plus c. So definitely this is going to give us, by 2 this is going to give us twice, by 2 this is 3, this is 3 times 3, which is 9 over 2, is going to give us 5, that is plus c, and definitely this is going to end up, our value of c is going to be 5 minus 9 over 2, and our value of c is a half. So after getting our value of c as a half, we have value of c, so we bring back this equation and we shall say, therefore our value of y is therefore going to be, our value of m is 3/4 of x, and the value of c is plus a half. So that is the equation of that line, and this is the equation in the slope-intercept form. So you can write the equation of this line either in the point-slope form or in the slope-intercept form. It will still be correct. So in this question, they're asking us to write an equation of the line containing 1, -3 and -4, 2. So in the slope-intercept form of the equation, y is equal to mx plus c is the general form of the equation. So it means that we are going to first have to find the value of m, the slope. After finding the value of m, then we shall go ahead and use one of these points to find the value of c. Then we shall substitute everything here to get the general form of the equation. So we first find the slope. And the slope here, the equation for the slope, or the formula for finding the slope, is y2 minus y1 over x2 minus x1. That's going to be y2. Now let's call this our x1, y1. This is our x2, y2. So our y2 is going to be -2 minus our y1, which is -3, minus -3. Divide that by our x2, which is -4, minus our x1, which is 1. And definitely there we are going to end up with, this gives us a plus, -2 plus 3 is 1. Divide that by -4, and -1 is -5. So our answer is -1 over 5 right there. So that's our slope. After finding our slope, go ahead and find the value of c, the y-intercept. So from y is equal to mx plus c, we shall just get one of these 2 points. One of these 2 points, let's get this one of 1, -3. So we are going to substitute it in here. So our value, this is x, this is y. So our value of y here is -3, so we shall say -3 is going to be equal to our slope, which slope we already got as -1.5. So it's going to become -1.5x. Our value of x here is 1 plus c. So this is going to become -3 is equal to -1 over 5 plus c. So making c the subject for the formula means it's going to be -3 plus a fifth. This is over 1. Our value of c is going to be So our value of c is -14 over 5. So definitely the equation, after getting our value of c, the equation is going to become y is equal to our value of m, which we got as -1 over 5x plus c. This becomes -14 over 5. Okay, so now I would like us to discuss parallel and perpendicular lines and how these two relate with the gradients of these specific lines. Right before us we are having 2 sets of equations, those that are in red and those that are in green. Now if you look at these sets of equations, they are all in the form of y is equal to mx plus c, and we say that that's the slope-intercept form of the equation. And we say that the value of m is representing the slope of the equation and c is the y-intercept. Now if you look at these ones that are in red, you will discover that the value of m is the same. This is y is equal to mx, the value of m here is 2, and the value of m here is also 2. So when you look at these 2 equations, the value of m is the same. But when you look at these other 2 equations, the values of m here are not exactly the same. They are just changing the signs. For example, if you look at this, the value of m is 5 over 2, and the value of m for this one is -2 over 5. Or by value of m, I'm talking about the slope, the gradient of the line. Now, in this first case, when the value of m is the same, it means that these 2 lines are parallel. So let's take it from there, that the parallel lines have the same gradient, or parallel lines have the same value of m. So that is how you tell that one line is parallel to another, when their gradient is the same. Now when you look at these 2 their lines, if you get the value of m here and the value of m here and you multiply them, you're going to get -1. For example, you find that the value of m here is 5/2. If I multiply 5/2 by -2/5, the answer I will get is -1. So with perpendicular lines, when you multiply their gradients, you're going to get -1 always. So it means that if the gradient of this line, let's say, was 6, the gradient of this line will be the negative reciprocal of this. So it will be -1/6. Why? Because 6 times -1/6 gives us -1. If the gradient of this line was, let's say, 4, the gradient of this line will definitely be the negative reciprocal of this one. So it's going to become -1/4. Why the negative reciprocal? Because when you multiply these two gradients, they should give us a -1. If the gradient of this line, let's say -6, it means the gradient of the other line will be the reverse of this reciprocal. So it will be +1/6, because when you multiply those two, it's supposed to give us -1. Maybe one more example. If the gradient of this line was a half, it means that the gradient of the other line is going to be the negative reciprocal of this. So it's going to be -2/1. When you multiply these two, it's going to give us -1. So that is the rule. When we're dealing with parallel lines, their gradients are always going to be the same. When we're dealing with perpendicular lines or lines that meet at 90 degrees, when you multiply their gradients, the answer you should get is -1. And the easy way to figure out the gradient of the other line when this other line is not been given is by simply quoting it as the negative reciprocal of the other, or call it the reverse reciprocal of the other. So to illustrate that further, we have a question here. Write an equation of the line containing 1,7 and is parallel to 3x plus 5y is equal to 8. First of all, we know that parallel lines have the same gradient. So we are going to first rewrite this equation in the form of y is equal to mx plus c, so that we are able to tell the gradient of this line. So this is this line we want. The line that we are looking for is passing through this point, but this same line is parallel to that. So let's rearrange this equation. This equation is 3x plus 5y is equal to 8. So we are going to make y the subject of the formula so that we put it in the form of y is equal to mx plus c. The reason for that is that so that we are able to find the value of m, so that we are able to know the gradient of that line. So that, because when we know the gradient of this line, then we can tell the gradient of the other line whose equation we are looking for. So it's going to become, this is going to become 5y is going to be equal to 8 minus 3x. And when we divide through by 5, by 5, by 5, this goes with that, we remain with y here. Our value of y here is going to become -3 over 5x plus 8 over 5. So meaning that the line we are talking about here is -3 over 5. So now the gradient of the line we are talking about here is -3 over 5 plus 8 over 5. So meaning it's going to be, the gradient is -3 over 5. Now the question is telling us that write an equation of a line that is containing 1,7. So it's going through 1,7 and is parallel to this line. So now if it is parallel to that line, the line we're talking about is this one right here. So it means that this is the gradient of that line. If the gradient of that line is -3 over 5 and this line is parallel to the line we're looking for, it means that this line we're looking for is also having the gradient -3 over 5. So we already have the gradient of the line we are looking for as -3 over 5. Now that we know its gradient, we can go ahead and find the real equation of the line. So we shall say that other line we are looking for, y is equal to mx plus c. So that line we're looking for, we have one of its points, it's 1,7. So y is 7 is going to be equal to the gradient m, which we have here as -3 over 5. -3 over 5 times the value of x. X is 1 plus c. So we are trying to look for the value of c. So definitely this is going to become 7 is going to become negative 3 over 5 plus c. When we make c the subject of the formula, c here becomes 7 plus 3 over 5. So our value of c is 38 over 5. So to go ahead and write the real equation of the line, our equation is definitely going to end up being y is equal to our value of m, which is the gradient, which we got as negative 3 over 5 x, plus c, which is 38 over 5. So here we are required to write an equation of a line that is containing this point and is perpendicular to y is equal to 4x minus 5. Now, these are lines that are perpendicular to each other. They meet at 90 degrees. What do we know about perpendicular lines? When we multiply their gradients, it is equal to negative 1, the answer we get. So this is in the form of y is equal to mx plus c. And the value of m in this case here is 4. So if the line we are looking for is perpendicular to this line and the gradient of this line is 4, it means that the gradient of the other line we are looking for is the negative reciprocal of this. So it is negative reciprocal, so it's negative 1 over 4. And when you multiply those two, 4 times negative a quarter should give us negative 1. So it means that that gradient of that other line is negative a quarter. So now that we have the gradient of that line, so now we can go ahead and find the y-intercept, the value of c. So we know that y is going to be equal to mx plus c. So now what's the value of y? We have, this is x, y, our value of y is 2, so 2 is going to be equal to m, which is the gradient, which is negative a quarter, times our value of x, in this case, which is negative 3, plus c. So we go ahead and find the value of c. So this becomes 2 is going to become negative 1 times negative 3 is positive 3 over 4 plus c. Our value of c in that case is going to become 2 minus 3 quarters. Now that we've got our value of c as 5 over 4, we can go ahead and find the equation of that line. So we know that the equation of the line is y is equal to mx plus c. So it's going to be y is going to be equal to our value of m. The gradient, we got it as negative a quarter. So it's negative 1 over 4x plus the y-intercept c, which is plus 5 over 4. And this right here is the equation of the line that is containing negative 3, 2 and is perpendicular to this. So we've been given point 2, negative 3 and point negative 5, 4. Find the length PQ and the coordinates of the midpoint. So we have this line right there. It is having point 2, 3 and it is also having point negative 5, 4. We are supposed to find the length and then the midpoint. First of all, to find the midpoint, let's first find the midpoint. The midpoint, we shall get the midpoint from x1 plus x2, divide that by 2, y1 plus y2, divide that by 2. So now our value of x1 here, let's call this x1, y1, and this is x2, y2. So it means that our value of x1 in this case is going to be 2 plus x2, which is negative 5, divide that by 2, y1 is 3 plus y2, which is 4, divide that by 2. And our answer definitely there is going to become negative 3 over 2, 7 over 2. These are the coordinates of our midpoint. Now to go on and find the length PQ of the coordinates, this was negative 3, this is 2, negative 3, so there's a negative 3 there. This is negative 5 over 4, so this 3 right here is supposed to be negative 3. So negative 3 plus 4 makes this a half. So the coordinates are negative 3 over 2, a half. That was a small error there. This is a negative 3, not positive 3 like we had earlier put. Now when you're trying to find the distance of a line, we are going to use Pythagoras theorem, but I would like to first show where it's coming from, then we'll go ahead and calculate. if this is our straight line right there, let's call this x1, y1, and this is our x2, y2. This, we form a right angle triangle right there. So it means that to get the distance from here to here, let's call this distance AB, or this is PQ. So this is distance P, that is distance Q. To get this distance here, it means that we're going to use the Pythagoras theorem. This side squared plus that side squared is going to be equal to this side squared. So to get the length of this side, it's simply going to be, these are the values, this is the y-intercept. So to get this, it's going to become y1 minus y2. Then to get the distance here, this is the distance of the on the x line, it's going to be still x1, the value of x here, minus the value of x here. So it's x1 minus x2. So it means that for us to get the distance PQ, it's going to be PQ squared, which is going to be equal to this side squared, which is y1 minus y2 squared, plus this side squared, which is x1 minus x2 squared. And definitely the general equation is going to be PQ is going to be giving us under the square root of y1 minus y2 squared plus x1 plus x2 squared. This is the general equation we shall be using when we are trying to find the equation, or when you're trying to find the length or the magnitude of a line. Call it the length of the line or the magnitude of a line. So in this particular question, we're having the 2 points, and it's just a matter of substituting them in here, and we get our distance PQ. And this is how we'll go about it. So for us to get PQ, we have, this is point P, this is point Q. We have our point here as 2, -3. We have our point Q here as -5, 4. So to go ahead and find the distance here, the distance PQ is going to be equal to under the square root of y2 minus y1. Let's call this x1, y1, this is x2, y2. So y2 minus y1, so it's going to become 4 minus y1, which is -3, this is squared, plus x2, which is -5 minus 2, and this is also squared. So we shall end up with, this is going to become 4 plus 3, which is 7. 7 squared plus -7 squared. And this is going to become 49 plus 49. This is going to give us the square root of 98. So the length of PQ is simply the square root of 98. In this session, we are going to do a series of multiple choice questions that require us to apply our knowledge of linear functions. So the first question will require us to find the slope of the line through points A, which is 3, -2, and B, which is -2, -3. Find the slope. Of course, here the slope is given by y2 minus y1 over x2 minus x1, and that is going to give us y2. Let's call this x1, y1, this is x2, y2. So y2 is going to become -3 minus y1, which is -2, divide that by x2, which is -2, minus x1, which is 3. We shall end up with -3 . The slope we get is a fifth, so definitely our answer here is 1/5. The slope of line 8x plus 12y plus 5 is equal to 0 is, so that we just have to rearrange this equation in the form of y is equal to mx plus c, and we'll be able to tell the slope. So this being 8x plus 12y plus 5 is equal to 0, we make y the subject of the formula. So it means 12y remains this side of the equation. This is going to be equal to 5 goes that side, and this 8, so it becomes -8x minus 5. Divide both sides by 12 by 12. This goes with that, you remain with y as -8 over 12x minus 5 over 12. Now, this is in the form of y is equal to mx plus c, and we all know that this is the gradient. So, negative 8 over 12, to simplify this further, by 2 we have 4, by 2 we have 6, by 2 we have 2, by 2 we have 3. So the answer is negative 2 over 3, that is the ultimate slope. So coming here, negative 2 over 3 is B. Here they're telling us that the slope of the line perpendicular to this line is, again, this is 3x minus 5y plus 8 is equal to 0. We need to arrange this in the form of y is equal to mx plus c, so that we're able to find the value of m, which is the slope of this line. After finding the slope of this line, then we shall be able to find the slope of the perpendicular line to this one. So we make y the subject of the formula here. Let's bring this negative 5y brings this side. This becomes 3x plus 8 is going to give us 5y, or if we rearrange it, it becomes 5y is going to be equal to 3x plus 8. Divide both sides by 5, all through by 5, so that this goes with that. You remain with y giving you 3 over 5x plus 8 over 5. So now, this is the gradient of this line. Now, a line perpendicular to this means that the gradient of this is going to be the negative reciprocal of this one. So meaning that if this is going to be, if the gradient of that line is 3 over 5, the gradient of the line perpendicular to this one is going to become the negative reciprocal. So it's going to be negative 5 over 3. Why? Because when we get this gradient of this line times the gradient of that line, when we multiply them, they're supposed to give us negative 1. So the answer here is negative 5 over 3. This is the gradient of the other perpendicular line we are looking for. And so here the answer is negative 5 over 3. The answer is A. So we have the y-intercept of the line through the 2 points whose coordinates are this and that. So definitely here we are just going to find the equation of this line, and then we will be able to find the y-intercept. So finding the equation of this line, remember the gradient y is equal to mx plus c. Give c is the y-intercept. So if we find the equation of this line in this form, we're able to identify the value of c, and the value of c is the y-intercept. So we begin by finding the gradient of this line, which so happens to be the value of m. So it means that the gradient of this line, they call it the slope, or the gradient, is going to be equal to y2 minus y1 over x2 minus x1. That's going to be y2, which is going to be 3 minus y, this is y2 minus y1, which is negative 2, divide that by 1, minus 5, that is going to be 3 plus 2, which is 5, divide that by negative 4. So this is negative 5 over 4. That is the gradient of this line. So to find the value of c, we are going to substitute still this y is equal to mx plus c, and find the value of c with one of these points. So we shall pick one of the points. Let's pick point 1, 3. So y is equal to mx plus c. So what's our value of y? Our value of y we've picked on this point. So our value of y will be 3. So it's going to be 3 is going to be equal to the gradient m, which is negative 5 over 4 times our value of x, which is 1, plus c. So we make c the subject of the formula here. C becomes is equal to 3. When this one comes, that it becomes plus 5 over 4. And when we add those two, the LCM there is 4. So our value of c here is going to be 17 over 4. So in this one, they're telling us that the equation of the perpendicular bisector of the segment joining points whose coordinates are this and this is. So they want us to find the equation of the perpendicular bisector of a segment that is joining points whose coordinates are this. So the interpretation of this is simply this, that we are having a line that is having this point 1, 4, and also it's having that point -2, 3. This line is joining these 2 points. But now these 2 points that are being joined, this line basically it's having what we call a perpendicular bisector. This perpendicular bisector, because it is a bisector, it means it is going to go through this line in the middle, because the question is calling it a perpendicular bisector. A perpendicular bisector meaning that first of all it is perpendicular, it is meeting this other line at 90 degrees, and it is a bisector meaning that it is dividing these 2 points into 2. It's passing exactly in the middle. So of course, for us to find the equation of this perpendicular bisector, which is one of these, is simply, one, we need to find the gradient of this perpendicular bisector. If we know the gradient of this line, the gradient of this perpendicular bisector is simply the negative reciprocal of the gradient of this line, since we already know that the gradient of this line times the gradient of that line is supposed to give us -1. Then also the second thing is that this perpendicular bisector, because it is bisecting this line, it is start passing in the middle. So we can get the point, one of the points that this line is passing through, which is in the midpoint of these 2 points. So we can first of all get the midpoint of this point, because it is where this line is passing. So the midpoint of this point first, then after getting the midpoint, then we can go ahead and find the gradient of this line, so that we are able to find the gradient of the perpendicular bisector, and then from there we shall be able to find the equation of this line. So to start it off, let's first find the midpoint of this line. So midpoint, the midpoint here is, it's going to become x1 plus x2 divided by 2, so it's going to be 1 plus -2 divided by 2, comma, then we have y1 plus y2 divided by 2, so y1 is 4 plus 3, divide that by 2, and definitely that is going to end up giving us 1 minus 2, which is -1/2, comma, this is 4 plus 3, which is 7/2. So this is the midpoint. This is the midpoint, and so meaning that as far as the perpendicular bisector is concerned, the perpendicular bisector is going through this point. So let's go ahead and find the gradient of this line. So to find the gradient of that line is going to be equal to y2 minus y1 over x2 minus x1. That is going to be equal to, let's call this x1, y1, this is x2, y2. So it means that our y2 here is 3 minus y1, which is 4, divide that by our x2, which is -2, minus our x1, which is 1, and therefore that is going to give us a 3 minus 4 is -1, divide that by -2 minus 1 is going to give us -3. Definitely that is a third. So the gradient of this line is a third. Now, so if the gradient of this line right here is a third, it means the gradient of the perpendicular bisector is the negative reciprocal of this. So it means it's going to be the negative reciprocal, which is -3/1. Because when you multiply this by that, it's supposed to give us -1. So it means that it is -3/1, or which is call it -3. So it means that the perpendicular bisector, its gradient is -3. So we already have two things. We have the gradient of this perpendicular bisector. We also have the point through which it is passing, which is the midpoint of these 2 points. So now that we have these two, we can go ahead and find the equation of this line using y is equal to mx plus c. So from y is equal to mx plus c, we know that this perpendicular bisector is passing through this midpoint. Let's call this point y, this is point xy. So y is 7/2, so we shall say 7/2 is going to be equal to our gradient m. We got our gradient here as -3, so it's going to be -3 times our value of x, which value of x is -1/2, -1/2 plus c. So we're trying to find the value of c. So this is going to become 7/2 is going to give us -3 times -1, which is going to be 3/2 plus c. When we make c the subject of the formula, c becomes 7 over 2 minus 3 over 2. Our value of c in this case is going to become 4 over 2, which is definitely giving us 2. So our value of c is 2. Now that we have known that our value of c is 2, we can go ahead and substitute in this equation to get our answer. So from y is equal to mx plus c, our value of y is going to be equal to the gradient m, which we got as negative 3. So it's going to become negative 3x plus c. Our value of c is 2. So it's plus 2. So we rearrange this equation so that it's equal to 0, so that we see which of these equations is here. So meaning that this is going to become y plus 3x minus 2 is equal to 0. Which is the same as 3x plus y minus 2 is equal to 0. And if you look at this equation, if you come here, 3x plus y minus 2 is equal to 0, our answer here is C. The length of a segment joining the points with these coordinates is, so now we are looking at the length of the segment. Of course, so we shall simply, this is x1, y1, this is x2, y2. When you're trying to find the length of the segment, let's call this segment AB. So when we want to find AB, AB is going to be equal to, we're looking at the square root of y1 minus y2, this is squared, plus x1 minus x2, and this is also squared. This is going to be under the square root of y1, which is 4, minus y2, which is negative 5. This is whole squared, plus x1, which is negative 2, minus x2, which is 3. So we shall end up having the square root of, this is 4 plus 5, which is 9. 9 squared is 81, plus negative 5, this is negative 5 squared is 25. So we shall end up having to find AB is the square root of 106. Now the square root of 106 is approximately 10.3. So our answer is 10.3. So the slope of the line parallel to the line whose equation is that is, so we know that parallel lines have the same slope. So meaning that if we have this, the slope of this line, we have the slope of that parallel line. So the slope of the line parallel to the line whose equation is this is, so what's the slope of this one? We rearrange this equation by making y the subject of the formula, so that we put it in the form of y is equal to mx plus c. So this is going to become 2x plus 3y is equal to 8. We make this becomes 3y is going to become 8 minus 2x. Of course, y becomes 8 over 3 minus 2x over 3. So if you look at it, this in the form of y is equal to mx plus c, this becomes y is equal to negative 2 over 3x plus 8 over 3. So this is the gradient of the line, negative 2 over 3. And since it is a parallel to that, the slope of the line we're looking for is parallel to this line, it means that that gradient is also negative 2 over 3. So the answer here is C. In this question, they're telling us that if the graph pi x plus square root of 2y plus root of 3 is equal to 0 is perpendicular to this graph, then what is A? Now, they're asking us to find the value of A. Now, if you look at this graph, it is perpendicular to that graph, and we find that this A they are asking is actually a coefficient of x, and we all know that in the form y is equal to mx plus c, that form of equation, the value of m is the coefficient of x. Let me write it here. Y is equal to mx plus c. The value of m is the gradient and it is a coefficient of x. And when you look at this equation, they are asking us to find the value of a, which a is a coefficient of x. So it means that what we are going to do, we are going to make this equation look like this one, so that we know the value of m in this equation. Then we are also going to make this one look in this form y is equal to mx plus c, so that this m is put in perspective so that we can easily identify the value of m. Then since the two, this one and that one, are perpendicular, it means that the gradient of this equation is the negative reciprocal of this. So let's get started with the working. So this is going to become this way. So we have pi x plus square root of 2y plus root of 3 is equal to 0. So what we're going to do here is to make y the subject of the formula so that we convert this equation in the form of y is equal to mx plus c. So this means this is going to become root of 2, y is going to be given by negative pi x minus 3. When we divide through by root 2, divide by root 2, divide by root 2, this goes with that to remain with y, giving us negative pi over root 2 of x minus 3 over root 2. Actually, this 3 is also under the square root. So this is y is equal to mx plus c. This is the value of m, the gradient. This is the gradient of this graph. But now remember, this gradient here is the gradient of this graph. Since this equation is perpendicular to that, it means that the gradient of this is supposed to be the negative reciprocal of the other. In other words, when we get this gradient of this, multiply that gradient by this, we're supposed to be getting negative 1. So looking at this, the gradient of this is negative pi over root 2. That's the gradient of this. So it means that the gradient of this one right here is the negative reciprocal of this. So it's going to be the negative reciprocal of this. The reciprocal of this is root of 2, divide that by pi, and that is still negative. Negative root of 2 over pi. So it means that, of course, negative times negative gives it a positive. So it means that the gradient of this thing is actually positive root of 2 over pi. And when you multiply these two, it's supposed to give us negative 1. So we know now the gradient of this. The gradient of this is now a positive square root of 2, divide that by pi. That's the gradient. So now that we know the gradient of that, so now we make this one become, we rearrange this equation into the form of y is equal to mx plus c. So the equation is ax plus 3y plus 2 is equal to 0. So we are supposed to rearrange that into the form of y is equal to mx plus c. So this is going to become 3y is going to be equal to negative ax minus 2. Divide both sides by 3. Our value of y becomes negative a over 3 x minus 2/3. So this is our value of m. This is our value of m, the gradient. So what happens is that we compare this to that, we equate the two since they are the same to get the value of a. So this means that this is going to become negative a over 3 is going to be equal to square root of 2 over pi. When we make a the subject of the formula, a becomes 3 times the square root of 2, divide that by pi, and this is negative. And of course, when you compute that, you're going to end up with this answer, C. In this video, we are going to talk about the vertical line test. Now, the vertical line test is simply a method we use to determine whether a relation is a function. Now, here is how we go about it. We draw an imaginary vertical line on a graph, such as this one. Now, if the vertical line intersects this graph exactly once, then it's a function. If it intersects the graph more than once, then it is not a function. So let's use the illustrations we have before. So before us we are having a quadratic graph. Now this quadratic graph is definitely a relation, but the question is that, is this relation a function? Now earlier we said that when we are dealing with a relation, if it is a function, one input is going to be exactly giving us one output. But if we are to use the vertical line test, we are simply going to draw a vertical line. So we shall get this and draw a vertical line right there. Anywhere we can draw it right there, or we draw a vertical line right there. Now when we drew our vertical lines, we realized that this line crossed this quadratic graph exactly once. Even this one, it crossed exactly once. So what does that mean? It means that this quadratic graph is an even function, because using the vertical line test, it is crossing this thing exactly once. Let's look at another graph. We have another graph here. This is our y-axis, this is our x-axis. We're having this graph, and we want to identify this relation to see whether it's a function. So using the vertical line test again, we are going to draw our vertical line like that. And of course, when we draw our vertical line like that, we realize that it is crossing here, it is crossing the graph here. So it is crossing that graph exactly twice, and we say that if this vertical line intersects the graph more than once, then this is not a function. So basically this relation is not a function. Let's look at another graph. We shall be repeating the same procedure here. Still, we are going to get our vertical line and we are going to draw like that. And when we draw our vertical line, it is intersecting the graph exactly once. And when it intersects it exactly once, then we say this relation is a function. And then finally, we have a circle, x squared plus y squared is equal to 1. Again, we shall do our vertical line test. We shall draw. When we draw it, it intersects at that point and at that point. And since it's intersecting this more than once, then it means that this relation is not a function. So one thing to really take note of is that before you really decide on whether a relation is a function or not, you have to make sure that you have explored all the possibilities. You try as many vertical lines as possible to make sure that the vertical line is going through either once or more than once. So in summary, we said that the vertical line test is simply a method that we are going to use to determine whether a relation is a function. And how we go about it is very simple. We draw a vertical line, and if the vertical line intersects the graph exactly once, then that graph that it has intersected is a function, or we can say then it means that relation is a function. But if it intersects it more than once, then that relation is not a function.
Yes, like this video. If you like it, be sure to subscribe. Check out other awesome content on the channel, and as always, thank you very much for watching. Take care.